Have you ever stared at a block of code and just wondered, how does that actually work? Well, today we're going to pull back the curtain. We're going to dissect a C program, piece by piece, to really understand what makes it tick. Let's dive in. It really can seem like magic, can it? You type some text, hit a button, and suddenly something happens on your screen. But I promise you, it's not magic. There's a beautiful, logical structure behind it all, and we're about to uncover it together. So, here's our game plan. We'll kick things off with functions, which are the absolute core building blocks in C. Then we'll zoom in on the most important one, the main function. After that, we'll talk about including header files, why comments are your best friend, and finally, we'll trace the incredible journey from source code to a program you can actually run. Okay, first things first, let's talk about the bedrock of any C program. Before you can build a skyscraper, you need to understand what a single brick is. In the world of C, our bricks are called functions. A function is basically a self-contained chunk of code that's designed to do one specific job. This whole idea is what makes C so incredibly powerful and organized. You can write a function one time and then call on it whenever you need it, which keeps your code super clean and easy to manage. I love this analogy. Imagine you have a toolbox. You don't have some weird, clunky, all-in-one tool, right? No, you have a hammer just for nails, a wrench for bolts, a screwdriver for screws. Functions are exactly like that. They're the specialized precision tools for your code. Now, in that big toolbox of yours, there is one tool that is absolutely 100% non-negotiable. It's the one you have to pick up first every single time. In C, we call that the main function. You could write 100 different functions, but your computer only knows one place to start looking, and that's main. Think of it as the front door to your house. When you run your program, the operating system walks right up to that door, knocks, and says, "All right, let's get the show on the road." And here's what it looks like in the wild. See that int main with the curly braces? Everything that's supposed to happen, all the action, it all goes inside there. It really is the engine that drives your entire program forward. Okay, so we've got our engine, main, and we know how to make our own tools, which are other functions. But what if we need some tools that we didn't build ourselves? I mean, who wants to reinvent the wheel every single time you need to do something basic? That's, my friends, is where header files come into play. This line right here, the one that starts with a hash symbol, isn't actually for the main compiler. It's a command for something called the preprocessor. It's basically you telling it, hey, before you do anything else, go find this other file and copy-paste all of its contents right here. So why bother with this? Well, the biggest reason is to get access to huge libraries of pre-built, ready-to-go functions. For example, if you want to print something to the screen, you need to hashtag include stdio.h to get access to the famous printf function. It's also a total game changer for keeping your own big projects nice and tidy. Let's switch gears for a second and talk about something that isn't for the computer at all. This next piece is for you, it's for your teammates, it's for anyone who ever has to look at your code. I'm talking, of course, about comments. That's right, the compiler just skips right over them. It doesn't care one bit. Their only job is to make your code understandable to humans. And trust me on this, when you come back to a project 6 months from now, you will be so thankful that you left good comments. They are literally notes to your future self. C gives you two main ways to do this. If you just need a quick note, you use the double slash. That tells the compiler to ignore everything else on that one line. But if you need to write a longer explanation, you can use the /* combo to open and close a comment that can span as many lines as you need. Okay, let's get into the really cool part, the transformation. How do those lines of text you so carefully wrote get turned into an actual program that a computer can understand and run? This is the journey from source code to execution. It's actually a multi-step process. First, that preprocessor we talked about handles all the hashtag include stuff. Then the compiler does its thing, translating your C code into the machine's native language. After that, the linker comes in and stitches everything together, your code, the library code, into one package. And finally, the loader puts that package into memory and hits go. And this diagram just lays it all out beautifully. You can see the flow, right? It starts with you, the developer, writing the code. Then it goes through that whole pipeline, preprocessor, compiler, linker, until it finally becomes that executable file, ready for action. When you really boil it down, that's the core job of the compiler. It's a highly sophisticated translator. It takes the code that makes sense to us humans and turns it into the raw ones and zeros that make sense to the computer's processor. It's the bridge between our world and the machines.
Whew. Okay, we've looked at all the individual puzzle pieces. Now, let's step back and see how they all fit together to make a complete picture.
And here it is, the whole shebang. You can clearly see each part we talked about. There's the hashtag include directive right at the top, bringing in our tools. Then you've got the main function, our grand entrance. Inside, you have a statement, which is the actual work being done. And finally, the return value. This right here is the fundamental anatomy of pretty much every C program you'll ever see. So there you have it. That's the blueprint, the skeleton of a C program. Now that you understand the structure, you have the power to build something. The only question left is, what will you create first? Thanks so much for joining me today.